Relations. Very important chapter and easy also. Simple, easy, and important. First of all, let's discuss about what is a polynomial. So let A0, A1, A2, AN are real numbers. Means, first of all, let us discuss about the word polynomial. Poly means many and nomial means term. Okay. When there are many terms in an expression, then it will be known as polynomial in the format given. So A0, A1, A2, and these can be real numbers represented by these alphabet A. Then f of x, function of x, that is that x is a variable here. Okay? X is not a constant. X is a variable here, and it is the degree of x is progressively increasing. Okay, and the constants are also there in the multiple with x with the variable. So when they are when constants are free, like this constant is free, it's with x is power 0, that's like it's independent. So it will be, we can call it as a normal constant. And these other constants which are there with some variable are known as coefficients of variables. Coefficients of variable. So this f of x in this format, in this decorum, is known as polynomial. Polynomial is known as a polynomial. So this polynomial will be known as a polynomial of degree n, because the power of x, the greatest power of x, is n here. Okay, so that's why we are calling this polynomial as a polynomial of degree n. There's one more condition here, that uh, the n should be a whole number or natural numbers. N should be whole number. Okay, and if we are discussing about the polynomial of degree n, then the constant should not be 0. If we are discussing about the polynomial of degree n, then the coefficient must not be 0, the coefficient which is coming with x raised to n. Otherwise, would it have been 0, then our degree of polynomial will become n minus 1. Okay, understood?
Yes, sir.
Yeah, so this was an expression, f of x. This was an expression, this was a function of x, polynomial. When we equate this to something else, then it becomes an equation. And here, particularly in this case, when I will equate that polynomial equation to 0, then it becomes an equation. And if the given f of x, the polynomial is of degree 2, that is, fx would be written as a naught plus a1 x1 x raised to power a2 x raised to power 2, that much only. If this is given to as equal as equals to 0, so this becomes an equation and is known as quadratic equation. The general equation of quadratic equation is given like this. Is given in this terms instead of using a0, a1, a2. Okay, where a, b, c are real number or complex numbers. The quadratic equation of the form ax square plus c, where the coefficient of x is 0. This particular quadratic equation is known as pure quadratic equation. Clear about what is quadratic equation, what is pure quadratic equation?
Yes, sir.
Yeah. So moving ahead, we have discussed about quadratic equation, and a should not be 0 here, because if a would be 0, then the quadratic equation will be written like this. And actually, it's not a quadratic equation now, it is a linear equation. Why linear equation? Do you know?
No.
linear equation, no problem. Linear equation because it is now having degree 1. Degree is what? The highest power of variable, which is x here. It's 1, so that's why this is known as linear equation. Okay. Now coming here, the numbers a, b, c are called the coefficients of the quadratic equation, and the number b square minus 4ac is called its determinant. Sorry, is called its discriminant. Okay, discriminant, capital D, is b square minus 4ac. This is discriminant of quadratic equation ax square plus bx plus c equals to 0. Understood?
Yes, sir.
It is by D. Yeah. So now let's discuss about formation of quadratic equation using roots. So as we know, this is a quadratic equation is a polynomial in degree 2. So there will be two values possible for x. Like this is the equation. So there can be two solutions for x. Let's say one is alpha and another one is beta. Okay. Do you understand what is the solution of quadratic equation? Means that when we will substitute the roots, these are basically known as roots. There are two roots. So whenever we will substitute these roots in the quadratic equation at the place of x, then the equation will satisfy. The left hand side and the right hand side will be equal. That is 0 is equals to 0. And same goes for the other root also. So roots are the solution of quadratic equation, means that will satisfy the given quadratic equation. Understood? Let me give you an example. Let's say this is a quadratic equation. Its roots are 1 and 2. So when we will substitute 1 here, 1 minus 3 plus 2. So 1, 2 plus 3 minus 3 is equals to 0. So it is the equation is getting satisfied on left hand side and right hand side. For 2 also it will happen. 3 2s are 6 plus 2, 4 to 6, 0 is equals to 0. Okay, so these two are the solution of the quadratic equation known as roots here. Understood?
Good evening, sir.
Good evening. So we have discussed about quadratic equation right now. First of all, we discussed about what are polynomials. Polynomials are basically progressive terms in which the power of variable is increasing progressively. Like a naught have x have a multiple with x, if x is for 0, then x is for 1, 2, 3, 4. So this is known as polynomials. And this particular term, these are constant. A naught, A1, A2, A3 are real numbers, which are constants, and x is a variable because it's a function of x. Okay, and n should be a whole number because it's in power. And whenever we are discussing about a polynomial of degree n, it means that the highest power of the variable is n. And polynomial means poly means many, nomial means terms. Okay, so polynomial equation is simply it is just simply when the function polynomial equates to 0, then it will be known as polynomial equation. And the polynomial of degree 2 is this, and if it equates to 0, then it will be known as a quadratic equation. Here we can see the highest power is 2, and there are three terms. There's a x also. And if the coefficient of x becomes 0, then it will be known as pure quadratic equation. Clear till now?
Yes, sir.
Yeah. Quadratic equation basically simple, whatever we have discussed earlier, that a must not be 0, otherwise it will become a linear equation. The degree of the equation will become 1. Okay, so a, b, c are the coefficients of quadratic equation. The number b square minus 4ac is called the discriminant of quadratic equation of a quadratic equation ax square plus bx plus c. So now this discriminant is important because it will tell us the nature of roots, and we will discuss it later on. Let's first discuss about the formation of quadratic equation using roots. So what are roots? Basically, roots are the solution of quadratic equation. It means that if there is a quadratic equation and its solution, its roots are 1 and 2. So it means that if we will substitute the value of x with 1, then the equation must satisfy. That is, to satisfy means LHS should be equal to RHS. Same goes for the other quadratic equation as well. So is this clear till now? Yes, Tanish.
Yes, sir.
Yes. Now let's go on to discuss that that how we can form a quadratic equation if there are two roots given. Let us say the question is form a quadratic equation having alpha and beta as roots. So do you know how to form, Kanish?
No, sir.
So yeah, no problem. So as there are two roots, so it's a quadratic equation. It's a simple thing to remember that we have to sum the roots, the sum of the roots into x plus the product of roots. Basically, this is how we can find out the quadratic equation using given roots. Okay, now let's discuss a question. If we have to form a quadratic equation of roots 5 and 4. Okay, now you tell me the answer, Anish, that what will be its quadratic equation? What should I write here?
X square minus 5. Sorry.
Sum of roots.
9x.
Yes. And what will be here?
20.
Yes. So this is the quadratic equation having roots 5 and 4. Now we have to form a quadratic equation of having roots 3 and 2. It's a very famous quadratic equation. X square minus, come on, speak.
X square minus
3 2s are?
6x.
Okay, my
5x.
mistake. 3 plus 2, 5x. 3 2s are 6.
6.
Yeah, this is a very famous quadratic equation. Similarly, we can find out the quadratic equation of any. Let's take one more example. Formulate quadratic equation having 2 plus root 3 and 2 minus root 3 roots. So now the answer will be x square minus into 2 plus 2, 4 plus root 3 minus root 3 is 0, x plus 2 root 3 into 2 minus root 3. So a plus b into a minus b. So a square minus b square. 4 minus 3 is what? So here will be 1, 0.
1.
X square minus 4x plus 1 is equals to 0. This is the quadratic equation which have roots 2 plus root 3 and 2 minus root 3. Clear?
Yes, sir.
Yeah. So quadratic identity means, let's say, x plus 1 whole square means it's a quadratic expression in x. If two quadratic expressions in x are equal for all values of x, this statement of equality between the two expressions is called an identity. Basically, x plus whole square, we can write it as x square plus 2x plus 1, right? So it's an quadratic identity. The degree is 2, and for all values of x, for all values of x, the identity, the given identity will hold true. Okay. And whether quadratic equation is an equation which will stays true for only two values of x. Okay.
Yes, sir.
Quadratic equation stays true. Stays true means when we'll put those two particular values of x which are its roots, then only it's going to satisfy. Okay. And for any value, like for all or any value of x, this will stay true. You can put x is equals to 0 to like any real number, it will be true. And even for the imaginary numbers. Okay. Imaginary, complex numbers. Yeah, so let's discuss about identical equation. Two equations are said to be identical if they have same roots. Okay. Two equations will be said as identical if they have same roots. Let's take an example. X square minus 5x plus 6 is equals to 0. And 2x square minus 10x plus 12 is equals to 0. So the roots of this equation are 2 and 3. The roots of this equation are also 2 and 3. So the roots are they have same roots. So these two particular equations are identical in nature. Okay, understood?
Yes, sir.
Yes. So the remaining is the concept of quadratic identity. Now let's discuss about the roots of an equation. We have already discussed it, that ax square plus bx plus c is equals to 0 is a function of x. So there will be two particular values of x for which the f of x will become 0, which are alpha and beta, which are known as its roots of the quadratic equation. Understood? The values of the variables satisfying the given equation are called its roots. If f of x is equals to 0 is a polynomial equation and f of a is equals to 0, then a is known as the root of the polynomial equation. It's the same. Understood?
Yes, sir.
There's one more. An equation of degree n has n roots, real or imaginary. Means an equation means any expression equating to 0 of degree n. Degree n means the variable having the number, the power, which is like, let me think and speak. The power, the highest power on the variable is known as degree, and any equation having degree n will have n roots. Okay, it will have n solutions. Like the quadratic equation having degree 2 will have how many solutions? Two solutions. So two roots will be there. And similarly, if any equation have degree n, then it have n roots. Maybe it can be real or imaginary. Okay, both will count. Is this point clear?
Yes, sir.
Now let's discuss if the next point. If an equation has a root a plus root b, then another root will be a minus root b. Or if an equation have a plus iota b as a root, then the another root will be a minus iota b. You will come to know after we discuss the next concept about roots of a quadratic equation. So for finding roots of a quadratic equation, we can have like two methods are there. There are two methods. One is basic factorization, basically observation. And second one is Sridharacharya formula, which is the ultimate. So let's discuss about factorization. If there is any quadratic equation given like, sorry, x square minus 13x plus 22 is equals to 0. If there is any quadratic equation like this, and we know the quadratic equation having two roots will be written like this. Okay. So we will not write this again and again. I'm just writing here so that you can understand. So we have to find two roots after like comparing these two particular equations. We know alpha plus beta is going to equal 13 and alpha beta will be 22. So we have to find two numbers which will sum up, which will add up to 13 and whose multiple is 22. So can you guess these two numbers? And for that, you can like simply do one thing. The product of these two roots, take its factorization. 22, 2 into 11, 11 into 1. Now out of these factors, we will have our those two numbers. Okay. Now think for those two numbers. Are there any which you are able to find out that whose those two numbers must be adding up to 30 and those product should be 22. Are you able to think for any solution?
Yeah, I'm just thinking, sir, but I'm not getting.
Just look at the factors of 22.
Now I have to find.
No, I have factorized the 22 here.
Okay.
2, 11, 1. So if we'll add 2 and 11, what we are getting?
13.
Yes, so these are two numbers, 2 and 11, whose product is 22 and sum is 2 and 11, sum is 30. So basically, these two numbers will be 2 and 11. So the roots come out as 2 and 11. As simple as that. Okay. Okay, if you need to find out this, so we do it in traditional method. 13 can be written as 11x minus 2 of x plus 22 is equal to 0. Taking x common, x minus 11. Taking minus 2 common, x minus 11 is equal to 0. Now taking x minus 11 common. Now here is x, here is minus 2 is equal to 0. So now x can be 11 or x can be 2. Okay, understood? Understood how we have find out the roots of a quadratic equation?
Yeah, sir.
So,
Yeah, it's simple class 9th concept. Yeah, so let's discuss about Sridharacharya formula. Now here b square minus 4ac is discriminant. So basically the roots will be minus b plus square root of d by 2a and x is equals to minus b minus of square root of d on 2a, because whenever we write square root of anything, we consider the plus minus value with it, right? So we can combinedly write this form as this solution as plus minus of square root d on 2a. So these are the two roots of a quadratic equation in which of the quadratic equation this ax square plus bx plus c, and d stands for b square minus 4ac, which is the discriminant. Okay, clear? Let me
Yes,
give
sir.
you an example, it will be more clear. So let's discuss about x square minus 24x plus 44 is equals to 0. So what is a here? Let's compare this given quadratic equation. Is just standard generally this general quadratic equation. So what is a here? What is b here? What is c here? Tell me.
A is 1,
A is 1,
B is 24,
minus
minus 24, then C is plus 44.
Yeah. Before that, let's discuss about one more thing, that is discriminant. Okay. Now we know the solution of quadratic equation using Sridharacharya formula will be written like this. Okay. And D is what? B square minus 4AC. So there can be three things with a number. A number can be positive, a number can be 0, or a number can be negative, right? If the number is positive, it's greater than 0, and so the roots will be real. Let's first discuss. If discriminant is 0, means basically what we are going to do further. After finding discriminant, we are going to square root it. Square root it. So we know the square root of only positive numbers exist. Yes, in real number. So that will be real numbers. So if the discriminant is positive, so we'll have real roots. Okay, and real numbers are also two type, because real numbers are this, like, right, the union of rational numbers and irrational numbers. So if the discriminant is a perfect square, perfect squares are what? Anyone aware? What are perfect squares?
Sir, is it um, like 4 square, which gives 16 like that?
Means these numbers are perfect square. Okay, and if D is not a perfect square, let's write otherwise here. So if it is a perfect square, then it is going to cancel this square root and will make a simple rational number, right? So the square root will be cancelled. So in this case, there will be rational roots. And if the discriminant is not a perfect square, we are not able to find out the square root. So the roots will be irrational. Same as in the case we have discussed earlier, where it was. Yes. Now, this is a rational number or irrational number? Come on, tell me.
It's a irrational number, sir.
Yes, this is a irrational number. This is also an irrational number. Now, the roots are irrational. Let us check whether what is its discriminant. A is 1, B is minus 4, C is 1. Discriminant is B square minus 4AC. So minus 4 square is plus 16. Minus 4 into 1 into 1. So 16 minus 4 is 12. We are missing something. Yes, 12, right. So now if we, so 12, discriminant is positive here. So roots will be real. Yes. Okay, roots will be real. Now we have this equation on this solution only. Roots will be real. Now we go on to find out the roots. Minus of b minus 4 plus 4 square root 1 plus minus square root of d 12 upon 2a. Okay, so now finding the square root of 12 is not possible because it's not a perfect square. So square root of 12 is can be 2, 6, 2, 3, 3, 1, 1. So it can be written as 2 root 3 because 2 square will come out. We can write square root of 12 equals to 2 raised to r 2 into 3. So 2 will cancel the square root and will come outside, root 3 will remain inside. So 4 plus minus 2 root 3 divided by 2. 2 will cancel 4 by 2 and 2 by 2 or 2 will cancel 2 by 1. So it will become 2 plus minus root 3. So now we come to know this is a irrational. These are irrational roots. Why so? Because the discriminant given was not a perfect square. 12 is not a perfect square. That's why the roots were going to be irrational. Clear?
Yes, sir.
Yeah. So this is how important discriminant is, that if it is positive, then the roots will be real. And if discriminant is positive and it's a perfect square, then the roots will be rational. And if the discriminant is not perfect square, okay, if it's not a perfect square, if discriminant is not a perfect square, then the roots will be irrational. And let's discuss about this fact that if discriminant, and also one more thing here, there will be real roots and roots will be different roots. Like they both will be different. Okay. In this case, when the discriminant becomes 0, root will be still real. And roots will be same. Why so? Why so? It happens in the case like when discriminant is 0, basically b square minus 4ac is 0. So b square is equals to 4ac. So when it is the case, okay, when it is the case, so our solution becomes x is equals to minus b plus minus square root of 0 upon 2a. X becomes minus ba upon 2a. So there is only one root, and now we call it, as it is a quadratic equation, so we call it that there are two roots and they are same roots. There are two roots. Let me give you an example. X square plus, sorry, x square x square minus 4 is equals to 0. X square is equals to 4. X is equals to plus minus 2. No. This is a different example. This is pure quadratic equation. There are two different roots here. They are not similar. They are not same. They are different. Let's take one more example in which b is 1 and a is half. C is half. Let's take this 1 and a and c is 1. I'm like formulating a question for you. That's why I'm thinking so much. So the given quadratic equation is x square minus 4x plus 1 is equals to 0. So this is the given quadratic equation. Now we find out the discriminant b square 16 minus 4 into ac. Still, I have done a mistake. There will be 2 here. B should be 2. It should be 2x. Now we find out the discriminant of the given quadratic equation. It is b square 2 square minus 4 into 4 into 1 into 1. So it becomes 0. So now in this case, the quadratic equation is basically x minus 1 whole square. So the answer is x is equals to 1. But we will say that there are two roots and they are same roots. Same roots. And real roots, d is 0. So this is how it comes out to be same roots, because discriminant is 0, so the root will be minus b by 2a similar. Simply. Okay, understood?
Yeah, sir.
Okay, now there's third case. If discriminant is a negative number, then roots will be imaginary and different. Okay. And remember the thing where we were discussing about if one root of quadratic equation is a plus root b, then another root will be a minus root b. And if one root of a quadratic equation is a plus iota b, iota, I have discussed about complex number earlier, remember? So then the other root will be a minus iota b, simply. So or even if only one root of a quadratic equation is given as this, so we'll be able to simply find out the another root. Understood? This page is really important. Okay. Are all these points clear? Any doubt? If any doubt, please ask.
No doubt, sir.
Any doubt? Tanish, please respond.
No doubt, sir.
Good response. Yeah, I was speaking with my mic off. So we were discussing about this quadratic equation. We were about to find its root using quadratic equation, using Sridharacharya formula. So A is 1 here, B is minus 24, C is 44, and we will find out its discriminant, that is B square. 24 square is 576. And do you all have remembered the formula, the homework which I have given to you? So I'm just testing. What is the square of 16? Tell me what is the square of 16?
256.
Used calculator. Now tell me the
Sir,
square
I
of
didn't
18.
use calculator, but I was putting 16 into 60.
Okay. So you calculated so fast.
Yeah, sir.
Okay, now tell me 18 into 18.
324.
324. Okay. So let's see who can calculate fast. Tanish or Yasini. 16 into 12.
16 into
12.
192.
Hmm?
192.
192. For sure.
Yeah, sir.
Good. And you can also like there are some tricks. I'll share it with you. Yeah, to calculate faster. Like okay, I'll do it later. What is the 14 square? 13 square. What is 14 square? First tell me this.
196.
196. What is 13 square?
169.
Good. Please remember all the squares and cubes till 20 and squares till 25. So square root 24 is 576 if I'm right. Square of 22 is 484. Yeah, 576. For A, 1 A is 1, C is 44. Okay. So D is 576 minus 4 for the 16, carry 1, 176. D is 004. So square root of D. So now the applying Sridharacharya formula minus of B, that is plus 24, square root of 400 upon 2A, that's 2. 24 plus minus. What is square root of 400?
400.
So 24 plus, yeah, 24 plus 20 upon 2 and 24 minus 20, that is 4 by 2. So this will become 22 and 2. These are two roots. Okay. Simple. Any doubts using Sridharacharya formula? Any doubts?
No doubt, sir.
Okay, so this is our first question. Okay. So this is the first example. Let's discuss it and solve it using prime factorization method, like factorization method, not prime factorization. So comparing it with the let's do it in mind itself, that there should be two numbers whose sum should be minus of 1, whose sum should be minus 1, and the product should be minus of 6. So those two numbers has to be negative, because if the product is coming negative, so one of those two numbers has to be negative. So it will be difference between two numbers. So the difference between two numbers is minus 1 when 5 minus 6, no, because the multiple is minus 30. And what about what about 3? 2 minus 3. 2 minus 3. If we subtract 2 from 3, so the subtraction will come out as minus of 1. And if we multiply 2 and minus 3, so its multiplication will be minus of 6. Correct? Understood? Understood?
Yes, sir.
Simply take its factor. Just take the product of roots factor, minus of 6. So 2 minus 3 minus 3 1. So you can, and also it can be one case that the negative sign may change. You just don't take negative sign here and find out two numbers and then look for adding them or subtracting them, whether they are satisfying our need or not. Okay. So here 2 minus 3 will do our job. X square minus 2 of modulus of x plus 3 of modulus of x minus of 6 is equals to 0. So we can write modulus of x in this format, right? Correct?
Yes,
And
sir.
we know x square can be represented as modulus of x square. No problem. Yes, they both are equal, right? Should I
Yes.
give example? Let's take minus 2. Minus 2's whole square will be 4, and minus 2's modulus is 2, and then its whole square will be 4. So simple, they can be written as this. Okay, so we are going to do the same. Modulus of x whole square minus 2 modulus of x plus 3 modulus of x minus 6 equals to 0. Taking modulus of x common, modulus of x minus of 2 plus taking 3 common, modulus of modulus of x minus 6 by 3 to 0. Now taking this common, understood? Now modulus of x can be 2 or modulus of x can be minus 3. So tell me, can like for any value of x, for any value of x, would its modulus be ever negative? Can modulus of any number be negative?
Don't know, sir.
Can modulus of any number can be negative?
No,
Why no?
because modulus is taken to just to make the number positive. No, sir.
Yes, that's why the modulus of any number cannot be negative. So this is not our solution. The solution is this: modulus of x is equals to 2. If we will solve for x value, x can be plus 2 or x can be minus 2. So let's look for the solution: plus minus 2. Understood? Is this question clear?
Yes, sir.
Great. This is our solution. So formulation of quadratic equation using roots, we can do so in this manner. And if we had to formulate cubic equations using 3 roots given, so we know a cubic equation having degree 3 will be having 3 roots. So name it as alpha, beta, and gamma. And if we have to find out cubic equation, if roots are given, so we'll use this equation, okay? Absorb it. Alpha plus beta plus gamma, alpha beta plus beta gamma plus gamma alpha minus alpha beta. And if we write a cubic equation in general form, it is written as ax cube plus bx square plus cx plus d equals to 0. Okay? And quadratic equation is given written as ax square plus bx plus c equals to 0. So now let's try to find out the relation between the coefficients of the general quadratic equation and the roots. Let's try to find out the relation between the coefficients of general cubic equation and the roots of cubic equation. Okay, shall we do it?
Yes, sir.
Okay, so let's first modify this equation, general equation. Let's divide by a on both sides to make the coefficient of x square 1, because it is the case here. Okay, so dividing by a on both sides, 0 by a becomes 0 only. So now if we will compare the equation number 2 and equation number 1 and equation number 2. So basically alpha plus beta minus of alpha plus beta is b by a. So we can write alpha plus beta is equals to, minus will go on to the other side, minus b by a, correct?
Yes, sir.
And if we compare the coefficient, like the constant with constant here, so alpha beta equals c by a, correct?
Yes.
Yeah, let's do it for cubic equation now. Let's try to make the coefficient of x cube 1, because it is 1 here. We are going to compare it. So x cube plus b by a, x square plus c by a, x plus d by a is equals to 0 by a, which is 0 only. So now you tell me what will be alpha plus beta plus gamma. Come on, compare these equation number 3 and 4 and tell me what will be alpha plus beta plus gamma. Sorry, not this 4. This fourth equation. Compare third and fourth equation and tell me what will be alpha beta plus gamma. Come on. Guess, no problem. Wrong answers are acceptable, but not the silence. So x cube coefficient is 1 there in the third equation. X cube coefficient is 1, so 1 is equals to 1. Okay. Alpha minus of alpha plus beta, the coefficient of x square is minus of alpha plus beta plus gamma, and the coefficient of x square is what? B plus a. So let's compare these two. So alpha plus beta plus gamma is equals to b by a, and the negative sign will also go on the right hand side. We can write it as minus of b by a. Now you tell me, on comparing the x coefficient of these two equations, what we will get? Alpha beta plus beta gamma plus gamma alpha will be equal to what? Please tell me. Try, no problem.
No, sir. I have no idea.
Just see the coefficient. Coefficient is what? Whatever the multiple of x is. What is the multiple of
C
x
by
is here?
A.
Yes, good. Sorry, repeat.
C by A.
Yes, c by a. Exactly. Now let's compare the coefficient, sorry, the constants only. So on comparing the constants, alpha, beta, gamma is equals to what? What?
D by A.
Hmm?
Is it D
D?
by A, sir?
But there is a negative sign here, and we have not written the negative sign on the left hand side, right? So the D by A will become
Minus
negative.
D by A.
Yes. So these are really very important formulas. Please remember them. And these formulas. Very important, okay? Now you have understood how we have calculated for these two formulas. Please learn them properly. Move ahead. Please observe this is the same. I'm going to take a pause here for some seconds. Please try to learn these formulas. These are very small formulas. And there's one more important point here, that if alpha and beta are the roots of a quadratic equation, then the equation can be written in the format this also. So ax square plus bx plus c can be written as a into x minus alpha into x minus beta. Okay, so these are 3 points. Please remember them.
Yeah, sir. Yeah, sir.
Done?
Yeah, sir. Gone through the slide.
Great. So now tell me, there is a quadratic equation given in this format. Now let me, okay, let's. So this is a quadratic equation and its roots are alpha and beta. These are two roots. So the sum of roots will be anyone?
Minus B by A.
Good. And the product of roots will be
C by A.
very good, very good. Let's discuss for cubic equation. How many roots will be there for cubic equation?
3, sir.
Alpha, beta, and gamma. So the sum of roots alpha plus beta plus gamma will be what? Simple and simple and. The sum of roots will be say minus b by a. This alpha plus alpha beta into beta gamma plus gamma into alpha will be c by a. And alpha, beta into gamma, the product of roots will be minus of d by a. Okay, there's also one more trick. The sign starts with a negative and keeps changing positives and the negative. Okay, so please remember them. They are very very important. And shall we conclude the class now?
Hmm. If so, okay.
Yeah, any doubts?
No, sir.
Okay. So, have you done the homework where I have asked you to calculate the exponent of 0.99 to the power 365?
No, sir.
Okay. That was just a Google search away. No problem. Okay, so thank you everyone. Good evening.
Thank you, sir. Jai Hind.
Jai Hind, sir.